We are now in section 4, shaders in Unity, and we're going to start off with an introduction to shaders and materials. These are two concepts that kind of get mixed up every now and then, so I'm going to clarify what each one is. Keep in mind that this was going to be a little bit of an oversimplification of some of the concepts, specifically when it comes to shaders, just because they are so complex. I really want to get the main points across without diving too much into the minutia. So let's get started. So let's start with, what is a shader exactly? So shaders are simple programs that are primarily used for graphics and effects. And I use the word primarily there as in the context of this course, so I put a little asterisk there. Shaders can be used for a whole lot more these days. In fact, you may have heard of something like compute shaders. Those are shaders that perform other types of operations. Still, they're generally used for graphics, but that is not a hard rule. And essentially, these are the written and specialized instruction sets in programming language like HLSL or CG or GLSL. When we talk about Unity, generally, we're going to be talking about HLSL. And this is essentially a very simple language that is very specialized to do a very specific thing, which in this case is shader. These are not general purpose programming languages. They're very specific. And more so, they are designed to run on the GPU. As opposed to a general, like a conventional program that's going to run the CPU, shaders run on the GPU. So then what is a material? Well, I couldn't really put this into very specific terms in my own words. So I have to admit I cheated a little bit, and I pulled the description from the Unity documentation, which I think sums it up perfectly. So materials define how a surface should be rendered by including references to the textures it uses, tiling information, color tints, and more. The available options for a material depend on which shade the material is using. So to illustrate that, let's look at this little diagram here. So essentially we have a material. It is a Unity asset, and it points to a shader, which is that program that's going to do something for the graphics. And then it exposes a certain number of shader properties to the material. So for example, textures and UVs and floats, etc. Let's take a look at what that looks like in Unity. So I have here my projectile material selected, and of course we did this earlier in the project, so this should be familiar to you already. But now we can sort of connect the dots. So this projectile material is pointing to the standard shader that is included with Unity, as are all these other ones here. And it exposes these properties here, which just basically tell the program what parameters to use when it's running. So for example, we have the color in the emission field here. We could have textures, float values, you name it. So the 3D rendering pipeline, in a very, very simplified fashion, you can think of it as, for example, in a 3D world, which Unity is, even for 2D things, it's using 3D sort of planes with images on them. It's taking the mesh information. So the 3D mesh, in this case, this sphere, it's taking all of the vertices and that information about the triangles and their normals and all that information and their UVs, and it's sending it to the graphics card. Then it's applying some standard lighting, and the lighting of course can be modified, lighting information and shading information and that kind of thing. And then finally, it applies whatever modifications were made by the shader itself. So what you get here is this third square here is what the user would actually see. So this is the output. So in comes the mesh, some basic properties are applied, and then the shader modifies that. There are a few different types of shaders that we want to be aware of. These aren't all, and they may be named something differently depending on what context you're talking about. But when you're talking about Unity shaders, you can generally categorize them into these three buckets. So you have shaders, which are widely used for modern games. They tend to be a little bit more expensive, but they're super robust. And the reason they're expensive is because they're going to operate in every single pixel, basically, that has that shader on it. As opposed to vertex shaders, which is our second type, it performs operations on each vertex. And so if you want to do sort of like displacement things or different sort of effects where you're changing the shape of a mesh, you can do it in vertex shaders, and it's super fast. It also works for vertex lighting, vertex coloring, and those sorts of things. Lastly, you have fragment shaders. So these operate at a per triangle level. So if we go back to our previous image, you can see that each of these meshes is broken up into triangles, which is the smallest possible piece of geometry that you can construct a mesh from. And so it'll collect the series of vertices, and then it's going to create a fragment, which is a triangle, and it's going to perform some operation on that. So again, if you want to do very complex things, you can do it with fragment shaders.